The purpose of this video is to review what a least common denominator is and how to make it. In Unit 8 specifically, there are a couple of different places where you need it. You need it for adding and subtracting rational expressions, and you also need it for solving radical equations when you multiply through by whatever the least common denominator would be. Let's start with doing least common denominators with numbers, and then we'll move on to doing them with variables. For this question, 1/8 plus 1/12, what I've done is I've come down here and I've already factored both denominators. So 8 is 2 cubed, or 2 times 2 times 2. 12 is 2 squared times 3. If you were doing this on your own, you might use a factor tree, or you might just be able to see it. A least common denominator accounts for all of the factors of all denominators. Let's start with that part. If we're going to account for all of the factors of this first denominator, well, at the very least, we need its factors. We need 2 cubed. So I'm going to put in our denominator here, there's definitely going to be 2 cubed because we need to account for this one's factors. Okay, now we also need to account for this one's factors. Let's see, 2 squared. Do we already have 2 squared accounted for? If we need a couple of 2s, in fact, we already have 3 2s, so we're good there. This one has another factor. It has a 3. Is that accounted for? No, it's not yet. And so we also need a 3 in this denominator. And this second way of saying things down here, all of the denominators can see themselves in the LCD. Here's what I mean, to personify these numbers a little bit. 8 looks at this denominator and says, I'm 2 cubed. Do I see myself there? Yes, I do. I see 2 times 2 times 2. Perfect. 12 looks at that denominator and says, I'm 2 squared times 3. Do I see myself there? Yeah, I see 2 times 2. It doesn't matter that there's an extra. I see myself. I see 2 times 2. And I see this 3. So this least common denominator contains all of the things that make up 8. It contains all the things that make up 12, and it doesn't contain any extras. And just to complete this part, I suppose, since this common denominator has a 3 that this doesn't have, we're going to multiply by 3 over 3 on that side. Since this denominator has an extra 2 that this one doesn't have, we're going to multiply by 2 over 2 on that side, if we were actually going to go ahead and add these. Let's do the same thing for these denominators, just higher numbers, no other difference. Again, I've factored them already. So if I'm going to make my least common denominator down here, I should go back and add, by the way, obviously, that would come out to 8 times 3 is 24. So that's what the least common denominator would be, but this is how you make it. Okay, back to this one. Start with, if we are going to have all the factors of all the denominators, we at least need all the factors of this denominator. So 2 times 3 squared times 5. Okay, now let's look at 36. 36 needs 2 squared. It needs 2 times 2. There's just a single 2 right now. In order for 36 to see itself in this denominator, there has to be 2 squared. Okay, so 36 sees that part of itself in the denominator. 36 sees this part of itself in the denominator. That's good. So that means that we've accounted for all of the factors of both denominators. This would be 4 times 9. Let's do this the easy way. 4 times 5 is 20. 20 times 9 is 180. And then we would multiply these by whatever we needed to. Okay, let's do this with, oops, wrong button. Let's do these with some variables now. Okay, so I'm going to write these out like this. This denominator is 2 times 5 times x squared. This denominator is 3 times 5 times x cubed. So if we're making a common denominator, again, we can just start with one of them and say, hey, we need all the factors of this one. So we need a 2, we need a 5, we need an x squared. Okay, so that accounts for all those. Now let's look at this one. We need a 3. We don't have a 3 yet. Put it in. We need a 5. We have a 5. Good. We need x cubed. We need 3 x's. We only have 2 so far. we need to have 3. And using this phrasing that both denominators need to see themselves in the least common denominator, 10x squared looks at it and says, I need a 2, a 5, and an x squared. That's what I am. There's a 2, there's a 5, there's an x squared plus some extra, but it sees the x squared that it needs. 15x cubed looks at it and says, I am 3 times 5 times x cubed. I see a 3, I see a 5, I see an x cubed. I see myself in there. And that would be the least common denominator. So in this case, it would be 10 times 3 is 30, x cubed. If you're dealing with things with powers like this, the least common denominator is always going to have the highest power. So if you see x squared and x cubed, there's going to be an x cubed. Okay, let's move on to this kind. So same starting point, that we pick one of them and say, well, we definitely need all those factors. So I'll just copy all the factors from the first one. Okay, this one's accounted for. The second one, we need an x minus 5. We've got an x minus 5. We need an x minus 7. We don't have an x minus 7 yet. So that needs to be included. The first one looks down at this and says, I am x minus 3 times x minus 5. I see x minus 3. I see x minus 5. I'm happy. The second one says, I'm x minus 5 times x minus 7. I see x minus 5. I see x minus 7. I see myself. They both see themselves, and we're good to go. So let's do one more that's just kind of got all the pieces to it. So I'll start just by doing the factored versions of these numbers. So this would be 2 times 3 times 5. And this would be 2 times 3 squared. So let's start with those. And in fact, we know we need all the factors of the first one. So we'll just put that in. We need a 2, a 3, a 5, an x, and actually 2 x plus 3s, right? And an x plus 7. So we need at least that. Let's look at the factors of the second one. We need a 2. We've got a 2. We need 3 squared. We need a couple of 3s. We only have one of them. Okay, we need to account for a couple of 3s. We need x squared, or we need 2 x's. We only have one of them. We need to have 2 of them to account for this. We need an x plus 3. We have an x plus 3. Yeah, there's another one, but this has what it needs. And we need an x plus 8. Don't see an x plus 8 yet. So we need to include that. And since this one's complex, so that would be our least common denominator. Since this one's complex, let's make sure we know what we need to multiply each of these by. And so actually, let's do 2 times 5 is 10, 10 times 9, so that's going to be 90, x squared, x plus 3 squared, x plus 7. You're not going to get one that has this many pieces, but you still want to know how to do it. Okay. To get from this denominator to this, what do we need to multiply by? We need to do this top and bottom. I'm just going to write it once. We need to multiply by 3. We need to multiply by x to get from x to x squared. We've got the x plus 3 squared. We've got the x plus 7. We don't have the x plus 8. We need to multiply by that. So that's what we would multiply this by on the top and the bottom. This one, to get from 18 to 90, we need to multiply by 5. X squared, we have. X plus 3, to get to x plus 3 squared, we need to multiply by x plus 3 again. We do not have the x plus 7. And we do have the x plus 8. So that's what, I didn't put that in a very good spot, but that's what we would need to multiply each of these by on the top and bottom to get this thing, which is our least common denominator.